Good morning, Algebra. Mr. Belke back with lesson 12-5, Probability Distributions. We're starting on page 672 in your books. If you want to follow along, here we go. So we're talking about random variables and probability to start. A random variable is a variable with a value that's a numerical outcome of a random event. A discrete random variable has a finite number of possible outcomes. So, in the situation at the top of the page, we have the owner of a pet store ask customers how many pets they have, and you have 0, 1, 2, 3, or 4. Okay? There were only 5 possible outcomes. It was fixed, so this would be a discrete random variable. So let's take a look at the first example. It says, find the probability that a randomly chosen customer has 2 pets. So, we want the probability that X equals 2 pets, okay? So we want 2 pets owned over the total number of surveys. And in this case, they made it nice and easy. They surveyed 100 people. And so we look at how many had exactly 2 pets, and that's 33. So there are 33 people with 2 pets out of 100 people surveyed. So the percent would be 33%. Of the people have exactly 2 pets. Okay? Now, part B says, find the probability that a randomly chosen customer has at least 3 pets. So in this case, the probability of X being at least 3. So X is going to be either greater than 3 or equal to 3. Okay? So there are 2 different categories that we're looking at. We're looking at all those people with 3 pets, which would be 18, plus all those people with 4 pets, which would be 9. And that's all over 100. So that's 27 over 100, which is 27% of the population. Okay? Now, a probability distribution is the probability of every possible value of a random variable X. So we can show that as a probability histogram, and that will show the probability distribution. Now, a probability distribution for a random variable can be given either in a table or in the histogram, and the distribution table and a probability histogram for the application at the beginning of the lesson are shown on page 673. But let's make one of our own. So let's look at example 2. Okay, the table shows the probability distribution of the number of vehicles per household for Columbus, Ohio. Okay, so we have 0 and 0.10, 1 car and 0.42, 2 cars, and that's 0.36, 3 cars, or 3 or more cars, and that is 0.12. Okay, so number of cars, and then the probability. Now, first, we need to show that this distribution is valid. And in order to do that, for each value of X, the probability has to be greater than or equal to 0 and less than or equal to 1. So, greater than or equal to 0 or less than or equal to 1? Yep. Now, the other part is they all have to add up to 1. So, does 0.10 plus 0.42, that's 0.52, plus 0.36, that's 0.88, and 0.88 plus 0.12 is 1.0. So that is also true. Okay? Now, if we look at part B, what is the probability that a household has fewer than 2 vehicles? Fewer than 2 vehicles. So that means they either have 1 vehicle or 0 vehicles. Well, the probability that they have one vehicle is 0.42, plus the probability that they would have 0 vehicles is 0.10. So the total probability of having less than 2 vehicles would be adding those 2 together, which is 0.52. So the probability of having less than 2 vehicles is 0.52. Okay. The last part, it says make a probability histogram of the data. Okay. So we could do that just like this. And let's say this is 0.10, 0.20, 0.30, 0.40, and 0.50. Okay, and then we had 0 cars, 1, 2, 3, plus. Okay, so 0 cars was at 0.10, so that'd be here. Fill that in. 1 would be a 0.42, so that's about right there. And we fill that in. 2 cards is 0.36, so right about there. And then 0.12, so right about there. All right. That's it for this lesson on probability distributions. As always, if you have any questions, please feel free to call, text, email, or join me online live tomorrow between 9 and 10 o'clock. Have a fantastic day. We'll see you tomorrow.